Welcome back to our YouTube channel. This is at Batlik YouTube channel for construction basic knowledge. Here we are trying to come up with the cast in situ stormwater drainage. So as you can see, we have provided some reinforcement that is in the excavated trench, and then now we will have to come up with a formwork that will give us the shape of the drainage. So as you can see from our screen, we have the shape of the drainage. So for us to attain this shape of the drainage, we took a pipe, we took a PVC pipe, and then we cut it into a half. So this PVC pipe is just to enable us to come up with the U shape. So we cut the PVC pipe into half. Remember that the diameter or the radius of the stormwater drainage is supposed to be 150. That is the radius, which means the diameter is supposed to be 300. So the PVC pipe, actually we cut it into a half, such that we can widen it to give us a semicircular form. That's for the drainage. So this diameter here is 300, and then we have used the marine plies, that is to enable us to come up with the walls of the drainage. And then you can see this timber here, which is a 2x1 timber. It will enable us to come up with the groove, that is for the cover, the concrete grating cover, that is for the drainage. So this is how we are going to attain this drainage. It is a cast in situ drainage, and this is how we are going to come up with it. But this is just a sample, it is a trial. We have done a 1 meter trial. So let's see the outcome, how it will come up, how it will come out. So that is the formwork that will enable us to get the required shape. And this is the reinforcement. Actually, this is now the outcome of our stormwater drainage. So we managed to cast it, and now this is the outcome. So as you compare it to the detail that we have, you can see we have the grooves. So these grooves, actually they will be to hold the grating, or rather the cover to the channel. So you can see this groove, the one that I'm pointing using the measuring meter. So this is the groove, and on this other side, this is the groove. So this groove will be to hold the cover to the channel, which we will do a concrete cover, but it will be perforated. So it will be a concrete grating cover. It will be a concrete grating cover on top of this channel. So let's see, as compared to our detail, we were to have a diameter of 300 millimeters or 30 centimeters. So let us see if we actually achieved it. So as you can see, that is from our measurements. As you can see from our measurements, actually our diameter is exactly 30 centimeter or 300 millimeter. So we managed to achieve the diameter as per the detail. So this is how we have managed to come up with the cast in situ storm water drainage. So but next time, or rather as we do the continuation, we'll make sure that now we at least achieve a smooth surface, such that actually we don't hinder the flow of water, such that the flow of water actually is also smooth. So these are some of the rectifications that we will be doing, but actually we have tried to come up with that. We have tried to follow the details as given. So this is one way of how you can do cast in situ stormwater drainage. So Let's have a look at it again. That is from this angle. You can see now, you can be able to see the grooves clearly. And I've said that if we confirm the diameter, you can see it is actually 30 centimeter or 300 millimeter as per the detail given. All right, so that is our channel. So we will be doing the entire length that we have been given with the same or rather we will be adopting the same methodology so that we can come up with this entire channel that is according to the direction of flow of the water that we have been given. So from our outcome, that is after casting the storm water drainage, you can see now this is the outcome. As I have already shown you, this is the outcome. So as per the detail, we are supposed to achieve 15 centimeter wall thickness or 150 millimeter thick wall thickness, that is on either side or rather on both sides of the drainage. But you can see for us we did a mistake whereby on one side we have more than 15 millimeter or rather 15 centimeter thick or 150 millimeter thick wide wall. So we have more. This is because during our excavation we did more excavation. We did more than 600 millimeter excavation. So that was the reason. But as we continue, we'll make sure that our excavation is exactly 600 millimeter wide, such that we achieve the width of the drainage as per the detail. So and as you can remember, our formwork, we didn't have formwork on the outer side, we only had formwork on the inner side. So this is our formwork that we removed. So this is the piece of the pipe that gave us the U-shaped of the channel, and as you can see, this is the timber, the 2x1 timber that gave us the groove. So that's the timber that gave us this groove, that is after removing the formwork. So on the outer side we didn't have the formwork, we only had the formwork on the inner side, or I can call it the mold. So we'll be doing actually the entire length of the drainage as per the flow, or rather as per the flow direction or the direction of the flow of water, and also as per the gradient given. So I was just trying to explain the as per the detail. We are supposed to have 150 millimeter thick walls or 15 centimeter, but for the outcome of our trial, on one side we have more, whereby we did more excavation. The width of our excavation was more than 600. So we are just supposed to, that is according to this methodology, we are supposed to do a 600 millimeter wide trench excavation, so that we actually achieve what we are supposed to achieve, so that we don't also end up actually having more concrete on one side. So but that is the outcome of our storm water drainage. So you can see the grooves again. So these grooves, they'll be enabling, or rather they will be holding the cover to the channel. the concrete cover or the concrete grating to the channel. So that is the outcome of our channel. That's the outcome of our channel. And also another correction is that we'll make sure that we achieve a smooth surfaces, that is to enable or rather not to hinder the flow of water. But this was our trial, that is to see how we can come up with cast in situ stormwater drainage. So that's how it looks like, and this is our formwork after removal. So this is the formwork that we used to come up with the shape of the channel. But remember, again, also we did reinforcement. We placed reinforcement, and then we had some or rather we placed also the concrete covers to the reinforcement, so that we actually achieve the required cover, that is to the concrete on both sides. So that is the outcome of our channel. So we will be doing the entire length, that's according to the direction of flow. And another correction is that now we will have to do a slope. We'll have to do a slope such that this slope will enable the water to fall into the channel, instead of just having the straight, because you see the flow of water is supposed to come from the pavement.